Hello, my name is Jason Deffenbaugh, and I'm a biological science technician with the USDA, and this is Dr. Alamu Mengistu, a plant pathologist with the USDA Agriculture Research Service in Jackson, Tennessee, and we're located on the West Tennessee Research and Education Center. We would like to welcome you to our presentation as we discuss soybean lines we've identified that have known resistance to soybean cyst nematode as well as charcoal rot. Charcoal rot is caused by the fungus Macrophamina phaseolina and can develop throughout the world on many economically important crops, including 500 plant species. This includes some of the most common crops we rotate with, which would be cotton, corn, sorghum, and the list goes on and on. Charcoal rot has been considered by some to be the most destructive soybean fungal pathogen of global concern. When it has no host to infect, charcoal rot can survive in the soil for up to 5 years. It also favors high soil temperatures and when plants are under drought stress. When severe, this disease reduces yield and seed quality in the United States. Estimated yield suppression for the United States and Canada averaged 43.9 million bushels per year, and a total of 219.6 million bushel loss from 2010 to 2014, making it the third most damaging soybean disease during those years. In fact, some of our research trials have shown a yield suppression of as much as 30%. Moderately resistant conventional lines have been developed by USDA scientists, but no current commercial cultivars have resistance. Symptoms of charcoal rot are evident in soybean plants of all ages, but most commonly occur in the later stages of pod fill. These symptoms develop first in areas with limited soil moisture, including sandy areas and hillsides. These stresses can also occur in irrigated soybeans if water is withheld during critical plant growth stages after the beginning of flowering. Plants infected after the seedling stage generally show no above-ground symptoms until after flowering. Initially, infected plants produce leaflets that are smaller than normal and show a subtle loss of vigor. Leaves may turn yellow and wilt but remain attached to the plant. The infected area turns gray to black, particularly under hot, dry conditions. This gray to black structure is known as microsclerotia. This gives infected tissue under the epidermis a grayish-black color resembling a sprinkling of finely powdered charcoal, hence the name charcoal rot. Microsclerotia on above-ground parts are first visible in stem nodes as profuse, small, black, randomly distributed specks. This pathogen may progress through the stem to the seed and in turn reduce seed size, quality, and yield. Soybean cyst nematode, or SCN, continues to be the #1 pathogen causing yield loss in soybean across the U.S. Some have called this a silent yield robber of soybean due to its limited control measures and sometimes showing yield loss without visible above-ground symptoms. Like charcoal rot, SCN depends on genetic resistance to help control this problem. These two diseases are both root diseases and have been reported to occur simultaneously in many fields across the country. As may be expected, when these two diseases occur together, their combined annual yield loss can be much greater than either one alone. The objective of our research was to evaluate and identify soybean lines resistant to charcoal rot from sources with known resistance to accessions from soybean cyst nematode. One thing we want to show you now is our charcoal rot evaluation process for screening lines for resistance, and that of course all starts at the beginning of the year at planting. One thing we also do at the beginning of the year when we plant is inoculate and furrow, and this just ensures that the fungus will be present so the plant can be properly evaluated towards the end of the season. And as we mentioned before, charcoal rot usually doesn't show visible symptoms until later in the soybean reproductive stages, particularly around R5 to R7. So it's at this time, right around R7.5, that we begin taking our plant samples. That may be 5 plants or 10 plants depending on the plot that we're using. But this needs to be taken with root material intact, since Microsclerotia can cling to that root material. And we've determined the proper sampling stage is R7.5, and this is when around 50% of the pods are their mature pod color, and 50% of those pods are still green. If we sampled any later, the plant has lost its ability to fight off the fungus if it contains any genetic capability to do so. At this point, all of our plants have been sampled, and we gather those plants up and split those down the middle as you see in the video, and that reveals to us this inner stem tissue, where we take our rating. And as mentioned earlier in a table, we use a 1 to 5 rating scale, and this is 1 being the most resistant to 5 being the most susceptible. And as you can tell by the discoloration in the stems, any amount of water and nutrients that is being taken up in that plant would be inhibited by the fungus, and thereby decreasing the plant's ability to yield to its full potential. After each set of plants have been rated, it is time to cut each stem and grind the tissue into a fine powder. I will eventually use this ground tissue and place it into a selective media, and charcoal rot colonies will grow, so we can quantify the amount of charcoal rot in each given soybean line. This is referred to as a colony forming unit, or a CFU. In this evaluation, 120 soybean accessions were evaluated, with known resistance to SCN, but unknown resistance to charcoal rot. Among these 120 genotypes, there were 8 maturity groups represented, 2 from maturity group 0, 4 in maturity group 1, 25 in maturity group 2, 25 in maturity group 3, 44 in maturity group 4, 11 in maturity group 5, 6 in maturity group 6, and 3 in maturity group 7. The reason, of course, for this wider range of maturity groups was to incorporate production systems not only in the Mid-South, but also in the northern production areas. After the evaluation was completed, we identified 1 line with complete resistance to charcoal rot, or a severity rating of 1 if you look at the table below, 10 accessions with moderate resistance, or severity ranging from 1 to less than or equal to 2. There were 51 that had moderate susceptibility, with a severity from just greater than 2 to less than 3, while 58 were susceptible, ranging from anywhere from 3 to 5 on the rating scale. 6 of these 11 charcoal rot resistant accessions were found to also have resistance from race 1 to 5 out of the total of 6 races of SCN, indicating that these accessions hold packaged resistant genes, something of course that all soybean breeders would look for when choosing genotypes to breed from. As was mentioned before, we found 11 resistant lines out of the 120 lines we evaluated. You might say, only 11 lines? Well, it may not sound like a lot to you, but to a plant pathologist, these lines are superior genotypes that can be used as potential parents in soybean breeding programs across the country for developing soybean cultivars with this combined resistance. And when this combined resistance is bred into lines, there will likely be a new line available to producers in the future that will most likely have a great yield potential. You might be wondering by now, well, what do I do to control charcoal rot in my field? I wish we had a simple answer for you. Some have said in the past that you should irrigate or rotate your crops. We've even seen data that a cover crop with rye may show good promise, but however, due to charcoal rot's wide host range, with most frequently used crops in rotations like corn and cotton, sorghum, sunflower, others, and also still finding charcoal rot under irrigation, as much as 30% as we previously mentioned in some of our research under those environments. Unfortunately, all these practices will not control charcoal rot. They could possibly lessen the severity of the disease, but it will not eliminate it. Practices such as choosing the best planting date, whether it be early or late planting, as well as plant densities, row spacings, and their effect on charcoal rot severity are being evaluated by our research projects. Above all, the best control measure will be to use resistant lines. Although we've already stated that there are no resistant cultivars commercially available, some do claim to have resistance. This has not been verified by USDA scientists, but we are working diligently to introduce lines that do have this superior resistance so you, the producer, can reap the benefits. Although we haven't provided you with a particular line for you to use in your field, we want you to know that we are passionate about what we do at USDA and are constantly working with you, the producers, in mind. As mentioned before, we do some very promising lines that show great charcoal rot and SCN combined resistance, and through collaborative work with the USDA and university breeders and as well as industry, we hope that these pyramiding of resistant traits become available to you in a line at some point in the future. If you have any questions for us, please email or call Dr. Mengistu or myself, Jason Deffenbaugh. Thank you for viewing our virtual no-till presentation, and we wish you the best of luck during the 2020 growing season.